Hello mga ka-electronics. Welcome back. This is our full explanation of our first short video that I posted in FB. You can watch this full video in my YouTube channel. Now, this is the full discussion, explanation regarding a power supply, comparing this computer power supply, which is they call this as SMPS or uh, switching mode power supply, and this one is an ordinary type power supply using a transformer. So I put on an LED display just to show you that this power supply now is turning on, and same also with this SMPS. Now see the fan is running now. Just a tip, no, sa mga beginners yung hindi nakakaalam regarding this computer power supply. Itong power supply kasi sa computer, pag hindi naka-plug in ito sa motherboard, kasi ang switch on nito is connected sa front panel ng motherboard, ng CPU rather, ng CPU. So, pag hindi ito naka-plug sa motherboard, kahit i-plug in mo pa ito sa outlet, hindi yan magpa-power on, no? So, ang secret nito guys is you have to short the two wires, this gray and green wires or wire, gray and green. You have to short that one so that this power supply will turn on. So nakita nyo mayroong jumper that's connected to green and gray. Okay, so now let's go back here. Ang purpose nito guys, nitong experiment natin is ipakita sa inyo yung difference between switching power supply and ordinary power supply in terms of the frequency, that they are using. So ordinary power supply like this is the frequency is based on the frequency of the source voltage or the outlet voltage, no? Okay, so our standard frequency is 50 hertz to 60 hertz depending on which country, no? So very usual is 60 hertz, meaning that frequency is 60 hertz frequency, 60 cycles per second. If we're going to measure the frequency, okay, no, channel 2, okay, the green signal. So look at the frequency. The frequency is around 59-60 hertz. Okay, so that's standard frequency for the household supply, 60 hertz. So it's fluctuating a little bit, 59 something to 60 hertz, 60 point something, but the actual frequency rating is 60 hertz. Now that frequency is from this power supply. That's the frequency based on the frequency of the main supply voltage. Now how about this is MPS? Okay, look at the frequency of this yellow signal. So we cannot view the actual signal since it is a higher frequency, much more than the 60 hertz. So, but if we can zoom in that signal using this our second perturbation knob, zoom, so we can zoom the signal, see the picture, you can zoom in, zoom out the signal. So we will try to zoom in the signal for yellow, okay, so that we can view the frequency, the wave. Okay, so that's the wave of this power supply, which is if we're going to measure the frequency for channel 1. Okay, so look at the frequency is reaching up to 28 kilohertz. Okay, that's 28 kilohertz, so it's very far from 60 hertz standard frequency of our household electricity. So 28 kilohertz. Why is that happening? And look at the okay, look at the wave. It's like on the top peak and the bottom peak of the signal is like a square. It's like a square wave. Okay, it's like a little bit looks like zoom in. It looks like a digital signal. Okay, because it's like a square wave. Why? Because again, the standard frequency of the household electricity is this one, this AC cord, AC line here. This 110 volts, or in other countries is 220 volts, 60 hertz. So going in, supplying this board. Okay, and after that, this is the primary section of this power supply, and this is the secondary section, secondary part. Now separated by this area, and this side, the primary side, is the primary winding of a switching power supply, and the secondary section is the secondary windings of the switching power supply, switching transformer as a whole is switching power supply, but we're talking here the transformer, a small, not this one, not this same with this transformer that relying only on the frequency of the household electricity, but this one, the power supply, the transformer here is, we call that a switching transformer, which is having an output of in terms of kilohertz because of the switching principle applied to this primary winding. So, and why this is looks like a square wave? Because to increase the frequency from 60 hertz, for example here, 60 or 50 or 60 hertz, then when going on this section, the primary, there is an oscillator here, somewhere here. I cannot pinpoint because we have to check at the bottom of this board. no? We can see only the welded components here. So, but there is an oscillator that produce this kind of frequency, that 28 point something kilohertz. Okay, here, no, that's why it is called switching. So it's a square wave. That's why it looks like, you know, the wave is like looks a square wave. So because of the oscillator here in this section, that produce actually a square wave at higher frequency rate, something like that, 28 point something kilohertz. Then switching this transformer to have an output at the secondary section. So comparing this to transformer, that there is a primary also and a secondary winding. So the primary is here, we plug in this outlet direct to primary winding, then convert that voltage to 220 or 110 volts to lower voltage depending on the desired output voltage of the transformer. In this case, this is a 12 volts transformer, 220 or 120 to 12 volts. So the output here is 12 volts. Look at the, you know, the tape for the winding inside, the red and blue. The red covered by red tape is a primary winding, and the blue tape is a secondary winding. So that's 12 volts. Then the primary winding is 220 volts. Now this one, there's no transformer like this. Again, it's a switching transformer, a small transformer, not this big transformer, because this one, the transformer for ordinary power supply, the size of the transformer varies on how much ampere you want to have in the output. Okay, like for example, in this case, this is, I think, only 750 or 300 milliampere, 750 milliampere, or not actually reach up to 1 ampere, because this is just a small transformer. So I think this is 750 milliampere or 0.75 ampere, something like that. 300 to 750 usually this size. Okay, then if you can see some bigger transformer, so meaning that transformer has a higher ampere rating, like 1 ampere, 2 amperes, 3 amperes, so on and so forth. So, but here, regardless of the size of the transformer, no, usually they have almost same size, not that big size. Okay, not that big size. So the concept here is like switching, no? Again, there is an oscillator here in this portion that creates or generate this frequency, 28 point something kilohertz. Then switch the transformer to have an output here, and so therefore whatever the frequency here in the primary, that would be also the output of the secondary section, but in lower voltage. Like for example, the output here, this is connected to motherboard, other computer components, peripherals, hard drive, CD drive, everything, motherboard, no? These are 12 volts, yellow is 12 volts, red color is 5 volts, and the rest is negative 12, negative 5. There are some 3.3 volts as like standby power, no? So those are the voltages here. So when you touch here, so it's not dangerous anymore because it's a low voltage. Don't touch on this section, okay? Never touch on this part, on this section here. These are the higher voltage section. This is the higher voltage rather section here, and these are the lower voltage here. So even you touch, see, it's working, it's running actually, but even here you can touch here. Okay, don't touch this section again. Okay, don't touch this section because this 220 or 110 volts, okay, supplying this section here. So that's the difference. Now, why the usually computers, why they prefer to have this kind of power supply compared to ordinary power supply? Because of that frequency, no? If your power supply has a higher frequency, it's not, hard for the designers, or easy, meaning easy to regulate, easy to like you don't need to have a higher capacitor or higher capacitance capacitor to put here as filter, because of this higher frequency compared to this lower frequency. Why, I will explain later on in our next video why this higher frequency power supply is easy to regulate and easy to filter than this ordinary power supply. What we are opting for in higher frequency power supply than the lower, based on the standard frequency of the outlet, which is 60 hertz. Whatever the frequency of the input, same also with the output frequency. So 60 incoming frequency, then the output is also 60 hertz. We're not talking the voltage. The voltage, of course, from higher voltage to lower voltage, but the frequency is still same, 60 hertz. So I will discuss later on why we preferred having a higher frequency power supply than this 60 hertz power supply, in terms of course, filtering and rectification. No? So later on we will discuss this different types of rectification, the bridge and the like half wave, and this is the bridge or the full wave rectification and filtering. So we'll discuss that later in our next video. By this time, only this one, I'll give you an overview what is switching power supply and ordinary power supply in terms of the frequency output. Okay, so now you see, we zoom in the yellow signal, which is the high frequency, but look at what happened to the lower frequency, the 60 hertz. You cannot read anymore, you cannot see anymore the correct wave because of this display. So we will zoom out back the display, zoom out again, so that, see, just notice the display. See, now we can view now the exact wave for the lower frequency, because during the time that we zoom in the display, this signal, the green signal 60 hertz, is like stretching that much, stretching that wave, so that you cannot see anymore the its wave, which is the alternating from positive to negative portion of the display, because it stretches like becoming a straight line. While the yellow one, since higher frequency, it has a higher frequency, and that's why you cannot read if you zoom out the signal. But again, if we're going to zoom in again, so yeah, see, look at that, the 60 hertz frequency is starting to stretch out. So that's why it's now, see, becoming then, but the yellow frequency, the higher frequency, is now slowly showing its normal signal, something like that. See, until such time that we can view now the whole picture of the signal. Okay, so much for that, guys. Wait for the next video for the rectification and filtering of this higher frequency and this ordinary power supply 60 hertz. Bye for now, guys. Bye.